All right, Halloween recording part two. Now we're going to work you guys through a real life example. This is from uh, the pumpkin patch last night. I took my daughter to the pumpkin patch, and I was, just as we're sitting there waiting in line for things, like I have her do things like we counted how many LEDs were on the Ferris wheel. We figured that at like 14,630, and doing mathematics and stuff like that. And I had her doing a little bit of this, a little bit of that. One of the things I had her do was I had her alphabetize letters, like in a word. It's like if you had carnival, if you alphabetize the letters in it, it would be like AACHIJKLILNRV. That look about right to you guys? Like if you alphabetize the letters in a string. And one of the words they had up on the thing, I said, all right, alphabetize allow. Like we allow these credit cards. Or oh, no, it wasn't allow. It was accept. Although allow also works for this example. And she's like ACCEPT. I'm like, no, don't spell it to me, girl. I want you to alphabetize it. She's like ACCEPT. I'm like, no, girl, I'm telling you, you need to alphabetize it for me. She's like, it's already alphabetized. And allow also is already alphabetized. And so that made me think. I was like, I wonder if my students can write a program that would figure out what the longest alphabetized word is in the English language. And I think you guys can all do it, but I'm not going to just give it to you as lab time because, like one of the students said that came to the meditation workshop on Saturday, is that like I let you guys do lab time, but I have kind of no way of telling if you guys are actually like working or not, like I have you screenshot and stuff after the lab's over. But so this time I'm going to have you guys work with me on building this, and we'll see how this goes for this. So our goal is to find the longest word in English that is alphabetized. Okay? You guys understand what we're doing? Now you need to tell me what step one is, because the engineering process, the computer science process, is you take a large task like this, and there's a lot of, this isn't super huge. This would be actually probably a good job interview problem question. But you need to take a task, you need to break it down into smaller tasks. And you break it down, and then sometimes you know how to do it, and sometimes you don't. But it doesn't matter. Right now, we're just going to break this down into a couple different subtasks. And then you solve the subtasks, and you put them together into a integrated solution, and then you have your solution. And so what is the first thing we need to do if we're going to be finding out the longest word in English? And there's actually no one right answer to this. I can actually think of several different ways that I might start this project. So how would you start? If we had to find the longest word in the English language that is alphabetized, what should we begin with? Download the dictionary? Find a file with the English dictionary, download it. Okay. That's what I would do too. Absolutely. So a lot of students said the same thing in the previous class, and they were like, oh, we need to Google it and download the file and use WinSCP and copy it. Don't need to. There is a command called locate, and we're going to locate the dict file on the server. And there's a lot of hits here, so we're going to pipe this through words, grep words, and there it is. That is our dictionary. So if we vim right-click that file, you can see that this file contains the entire English language in it. Yay, that's cool. It's 102,000 lines long. So it's even got words that have like fancy E's on it and stuff like that. I'm not sure how those alphabetized, to be perfectly honest with you. Let's find out. Okay. So there's the file. So how do we open this file? What do we do? Is it technically complete? I don't know, but it's a good start, right? So in Unix, every Unix installation comes with a dictionary file. It's called a words file. And it's useful for things like this. Like if you want to make crossword games or a hangman or something like that, you just open the thing up, load all of the things. Well, I'll let you guys come up with that, how to do that, step 2. And then you like make a hangman game out of it. So you don't need to, type your own dictionary. What do we do? ifstream, perfect. So I'm going to say ifstream ends, and I'm going to open up the dictionary file, and there we go. We have now opened up the English language. So what data structure am I going to use? I want to load all of these things into my program. What should I load into? What should I make next? What variable should I make? What data structure should I use? Vector, why not? It's the only data structure we really know, so sure, we'll make a vector of strings named vec. Let's do this. Then, how do we load from a file into a vector? This is something, when you get enough experience, you stop looking at like each individual semicolon and each individual if statement, and instead you sort of zoom out a little bit, and you're just like, I know how to load from a file into a vector, and you just go bloop, and you just do that, and you don't really think about it because you're kind of operating on a higher level. It's like the big brain meme where you have the transcendence. You stop thinking about like each iteration and like, okay, the first time through does this, the second time, and so you're just like, I know how to load from a file into a vector. How do I do that? It becomes second nature. Yeah, get line in a while loop, perfect. All right, let's do it. Also, anytime you open a file, you should probably check to see if an error occurred. Yeah, maybe. Yeah. Do we care? I mean, we know it's there, but why not? I'll just call die. Okay, void die, and die is just gonna see out. Actually, let's do this. Okay. Const s equals. Okay. So, have you guys ever seen this before? This is something called a default parameter on a function. This is a default parameter on a function. And so what this does is if I don't pass any parameter to die, then it will default to bad input. And that's usually what I want when I have a die function. When I call die for all of our homework assignments, it usually just prints out bad input and quits. But that's not a very useful error message, and it's not very professional. We do this because it makes the autograder easy. It's not like how you should be coding things. Instead, you should print out an informative error message, right? And so in this case, this isn't anything that's going to be auto-graded, so who cares? I'm going to give it a better error message. I'm going to say, could not open the dictionary. Okay, and so if this happens, let's just do that. And so if that happens, then it says could not open the dictionary file instead of bad input, right? If I pass it in with nothing, if I pass in nothing, then it just says bad input. But if I do it with a parameter, then it uses that error message instead. This is a very nice, sophisticated way of doing functions. A lot of the times, a parameter to a function will be the same 99% of the time, but every so often you give a different parameter. And so having a default parameter like this is super nice and useful. Although, to be fair, some people hate them. So just so you know, in the group of educators putting together like the C++ education standards, they hate default parameters. So don't know what to tell you. I like them, but I don't know. Don't know what to say. So, okay, so we got this. So now we need, what was that, a while loop? Let's do this. So we'll do a while loop, we'll do a get line, and sure, why not? String s, get line from the file into s. Every word is on its own line, so we don't need to do any splitting or anything like that. So that should be pretty good. If you want to use my read library instead of get line, we can use read line. And that's a little bit less typing. It's on one line. I kind of prefer this just because it's all on one line. You don't have to make a variable and use a variable. It's all on one line. So about the same thing. This is part of read. Okay, now we need to see, did we hit the end of file? All right. So if we hit the end of file, then we're done, we break. And so this coding pattern of having an infinite loop with a break inside of it is a very great, very powerful coding technique that you use whenever you don't know how many things there are. There's not a for loop because I don't know how many lines are in the file. So it's just a infinite loop. And then when we hit the EOF, break, we're done. If we didn't hit the end of file, then what? You tell me. That's it. Just keep reading. We need to do something with it. We're missing a very important line here. Probably add it to the vector, right? Add to the vector, but we need pushback, sure. But here's the thing about the words file is that it's got capital letters in it, right? And so I kind of don't want there to be capital letters, or maybe I want everything to be capital letters. You know what I'm saying? Like capital letters are going to like mess up with the alphabetization because they're in different parts of the ASCII table, and I just kind of don't want to deal with. Is capital A smaller than lowercase n? No, it's not. It's bigger. I don't want to deal with those issues. So we do not need a string here because every line is just one string. So we just read until the new line, done. So what should we do to handle capitals in this file? Switch it to the first letters not capitalized. What about all the letters? Because sometimes it's like an acronym and they have like 3 capital letters in a row. To lower or to upper? You guys tell me. Do you want everything all capitalized? Do you want Apple to become Apple? Or do you want it to become Apple? Which one? To lower? Cool. All right. So let's make a function, and this function is going to be called void lowercaseify. It's going to take in a string s. Should this be passed in by reference, by const reference, or by value? We're going to pass in a string, and we're going to modify it so that it's all lowercase letters. Should it be value, like it is right now? Should it be by reference, or should it be by const reference? We're going to make it by reference. Why not const reference? Well, because we're modifying it. Remember, const reference is if we're not modifying. And most of the time, we don't modify things when we pass them to a function. In this case, we are. The whole point of this is to lowercaseify the string. So we're going to say for every character by reference in string, that character is equal to the lowercase version of that character. And there we go. So now we've got a function called lowercaseify, and we will pass in s to it, and that will change every letter in that string to the lowercase version of that letter. Beautiful. We add it to the vector, and now we should probably test our code because we haven't actually compiled or run our code yet, so we probably should get on top of that. So we'll say for every const string reference string vector, see out the string. So this is how you print a vector. You notice how I didn't really have to think about that, right? It's not like I'm thinking, okay, the first time through the loop, it's going to be apple, and the next time through the loop, it's going to be banana. Like, I don't have to. And the reason for that is because, again, after you've been coding for a while, you need to be able to just kind of zoom back a little bit. Like this block of code right here is the block of code I use whenever I load from a file into a vector. I don't think about it. It's second nature. I read a line. I do some error checking on it. Like for rainfall, I check to see if it's a negative value. Here I'm filtering out all the letters, so they're all lowercase. You typically read a set of data, you filter it, and if it's really bad, you might die, actually. Like if you try opening up the Pokemon database and it's missing some crucial data like the names of all the Pokemon or something, you might actually just kill the program and be like, yo, your input file's bad. It kind of depends on your needs. A lot of times, like if you just have one line that's corrupted, you just ditch it and there's just no Pikachu, and then anytime Pikachu appears, like you need to handle that too. And like put in like an understudy that'll just a person in white that's going Pika, like it's really bad. It's really unprofessional for your code to just like die and crash. If you're making a Game Boy game and your code crashes, like people get really mad at you. And so you need to be able to handle a lot of different faults and a lot of different errors and handle them in a kind of a smart way. And so if you're doing input during like the development cycle, if you're doing it during like the development cycle, and somebody making the data files like screws up, like you want it to just fail and be like line 50, somebody typed in Pikachu and they forgot the health or something, right? And you tell them, and it quits and it doesn't run. You tell them line 50, Pikachu doesn't have a health value, fix it. You left it as a 0. You can't have a 0 health. No, bad. But when you release, you probably want to have your code be like, well, if they don't have a health, set the health value to 20. You know, like you have kind of like self-healing code that like if something gets corrupted, like you kind of try to fix it somehow, you know? And the original Pokemon was famous for having like the glitch Pokemon and things like that as well. So you want your code not to just die, right? And you want it to be able to handle reasonable errors and not like just implode, you know, at the first time somebody sneezes on it. Okay, so let's print the vector. Right, exactly, Alessandra. Zoom back. You zoom out and just be like, we're printing a vector, right? And you can just knock that out. I'm going to load from a file into a vector. You've got all these tools in your toolbox. And you're just like, boom, there it is. Boom. I know how to load from a file into a vector. Boom. I know how to print a vector to the screen. Boom. And you don't think about it. That's the level that you're thinking at. You zoom back and you're just like, that's what I'm going to do next. Could not open the dictionary file. That's because I forgot to put the exclamation mark back in there. Go me. All right, there we go. And here we go. So there is all of the words in English. That's interesting. There is no lowercase version of the A with a circle above it. Well, I don't know exactly how to handle that, actually. So you see like Abbott is like lowercase now. So all these things seem like they're working fine. Adrian, oh, that's a great name. Adrian. What the heck is that anyway? What English is this? I don't know, dude. What is that? Cultural hero, mythic status. Ruled Madagascar. All right. So that's a giant name. Okay. Cool. All right. So everything's lowercase. Everything looks good. Beefaroni is a English word apparently. I still don't know what we're gonna do with these fancy characters here. Maybe we filter them out. Like I don't know. Is that do you guys want to get rid of these things and just we don't have to look at them anymore? Like, or we just ignore them? I don't know. Like you tell me. What should we do? Yes. What? Yes. Which? Do we filter them or do we just like kind of ignore them and just be like, all right, well, if Angstrom turns out to be alphabetized with two fancy characters in there, it is. I don't know. Filter them. Okay. So, okay. So bool is valid English, and we're going to take a string, and we're going to return true or false if it is all standard ASCII characters. Like maybe we'll get rid of like the apostrophes too. Yeah. Okay. So should this be by value, by reference, or by const reference? This should be by const reference. Why? Because I am not deleting things out of the string. I am returning true or false if that string is Coolio or not. So if so for every character in the string, if that character is not, should we allow numbers? I don't think numbers make sense for this, right? Because we're trying to find the longest alphabetized word. I don't think we should allow numbers. I don't think we should allow apostrophes. What do you guys think? Like ABC 1, 2, 3, 4. Is that alphabetized? Like I don't know. Like you tell me. No numbers? Okay, discard numbers. Okay. Okay, so if we get anything that's not an alpha, so if not is alpha, so anything that's not an alpha, we are going to return false. Okay. And if we get to the bottom and everything in there has checked out, we return true. And I kind of want to do something else. I kind of want to say like if s dot size is like less than or equal to 2, return false. Because it kind of makes like I kind of don't want to see like T. That's alphabetized. You know what I mean? Like it's alphabetized. So I'm this is kind of sketch. Like this is kind of sketch. Yes, thank you, Vim. But do you guys want that in there or not? Because I'm kind of tempted to just filter out everything that's not, you know, everything small, like random like of and no, it's fine. Oz, you know, filter it. Okay, we can't ignore it. I'm not in love with that line, but let's just do it for now. Okay, so what we're gonna do is so if every character, we're gonna go through every character, and if any of them are not alphas, alphas are A through Z, right? If any of them are not alphas, return false or not valid. So we need to check this here. Okay, so if not is valid English us, then we will just continue. And this is what you're going to be doing on the Pokemon assignment. If you ever find a Pokemon move that has a hyphen in it or anything like that, you just continue, right? You go back up to the top of the loop and read another line, and there you go. Okay. So we do this and run it. Yeah, no more Angstrom, no more Eclair, sad. None of those apostrophe S's are in there, so no short letters. Everything's at least 3 letters long. Okay, looking good, looking good. All right, now we come to the meat of the problem. We've got a, we comment that out, because we're probably going to use it again in a second. So now, I'm going to open it up to you guys. We've got a vector with all of the English language in it, minus any weird characters, minus any numbers, minus any short words, minus apostrophes. We got the entire English language in vec. How do we find the word, the longest word that is alphabetized? What's our next step? What should we do here? And I can think of a couple different ways of doing this. So, what do you think? A loop with a temp, a while loop search. Okay. So we're going to be looping over the vec. All right. What are we searching for? A loop with demo, like demolitions. What are we searching for here? Looking for the longest string. Well, how do we find the longest string? Long words, just long words. A nested loop that looks for alphabetized words and sorts their sizes to temp. So we do, okay, so what you're suggesting is we write a function that determines if a word is alphabetized. And if it is, we add it to another vector or something. And then we find the longest word in that. Max, size, and save it to high score variable. How we usually replace the number with a new maximum with letters this time. For loop using ASCII values of characters. Interesting. Looking for longest string. Okay. So how do we? Here's one question. How do we find the longest string in English? There's a couple different ways of doing it. You could just iterate over it and then like write down the biggest word you've ever seen. What's going on, girl? And then you find a bigger one. That one knocks the other person off the. Oh, like it, girl. Look at this. Very cool. You're dressed up. You're ready to go. Your friend wants to hear. Go call your friend. Close the door. Yep. Okay. So a simple way that's not the most efficient but very easy to write is you can just sort the vector by size. Right? Anyone know how to sort a vector? What's the name of a function in C++ that will sort a vector for you? There is sort, but if you sort a vector of strings, it's just going to sort it alphabetically, and it's already kind of alphabetized. So that won't do anything. So what we need to do is come up with custom sort. And custom sort is, in fact, the second learning point for today. The first learning point for today was exceptions. The second learning point is custom sort. Okay. So if we do something like this, sort vector.begin, vector.end, this will sort alphabetically. And it's already sorted alphabetically, so this won't do anything. Okay. So what we want to do is sort by word length. And we can do that by passing in the name of a function here, which we're going to have to write. And we're going to call it like compare by string length. I'm not in love with the name. And so we're going to have to write a function that returns true or false. Compare by string length. And it's going to take in 2 const reference strings. And we need to return true when one of them is bigger than the other. And if we do this, if we write this function correctly, then when we call sort, sort can take in a third parameter. And the third parameter there is what it will use to sort the string. By default, it just does it alphabetically, but it doesn't have to be. Instead, what we're going to do is we're going to sort it by length. So all we have to do to sort the entire vector by length is come up with a function that will compare two different strings and return true if the first one's bigger and false if the second one's bigger. So how do we write it? We want to return true if S1 is longer than S2. How do we do it? Vector.size, there's string.size, yeah, okay. So we got S1.size and we got S2.size. How do we use these things? How do we write the code? Involve recursion? It's way overboard. All we need to do is just return true or false. Which one's bigger? S1? If S1's bigger than S2, true. If S2 is bigger, false. You guys understand? How do I write it? Give me some code. Give me some code. If true, else false. Okay. So if S1.size is greater than S2.length, return true, just to troll people. Size and length are exactly the same function. They just have two different names, and people will get mad if you do that. Else return false. Okay. Sorry, I can't handle that. Size and size or length and length. Mixing and matching will drive people crazy. Is there a more compact way of doing this? If true, return true. If else, return false. Is there a more compact way of writing this? Ternary operator? Not needed.
Yeah. Am I going to fencing today?
You got...
I'm already in my fence.
I guess not. You just need one return. That's correct. So all you do is you say return S1.size is greater than S2.size. Because remember, the comparison operator returns true and false. So if S1 is bigger than S2, it returns true. If it's not, it returns false. Done. So now, this sort function now is going to sort everything greatest to smallest. And if you think it's awfully easy, it is. It is actually really easy. This is a very powerful technique, by the way. You sort things all the time in computer science. My CSci 26 students right now are given a text file containing all of the cities in America with their latitude and longitude coordinates, and they have to sort them from west to east. And so in order to do that, they have a class for a city that's got latitude, longitude, and a name. And they they make their own custom comparison function that takes in two cities and returns true if one is west of the other. Easy. Right? So all you need to do is make a function. Oh, I don't know what happened there. All you need to do is make a function that tells C++ how you want to sort the things. I want S1 to be, I want it to be true when S1's bigger than S2. Cool. If you have a function like that, you pass it as the third parameter. Note there are no parentheses here. I'm not calling the function. I'm not calling the function. I am passing the function as a parameter to sort, and then sort is going to repeatedly use that function to put all of the elements in vec in order from longest to shortest. Okay? That is a spicy one-liner. So now all we need to do is find out which ones, we're just going to go down the line. The first time we find one that is alphabetized, we're done. We don't have to do like max or any of this stuff. Sort, as I said, this isn't the world's most efficient algorithm. It's not bad, though. It's not like super bad. It's not the fastest, but it's fast to write, and that's got a value all of its own. So we're just going to sort the strings from biggest to smallest, and now we need to find out who is the... Find out if a string is alphabetized. How? How do we do that? Give me some answers. Give me some answers. We're gonna be doing some sort of for loop, right? We're gonna say like for const string reference s. So for every string in the vector, if it is alphabetized, print it and quit. That's it, right? Because we've sorted it from longest to shortest. The first one we found that is already in alphabetical order, we can just print it out and quit, and we're done. It's as easy as that. So how do we tell, though, if it is alphabetized? Look at the things before and after, see if it lines up alphabetically. Custom sort the letters, not needed. Ideas, fun. Why don't you guys come up with this? I just checked. There's actually a standard library function to do this, but how would you do it if you had to write it? There is a standard library function called isSorted. So you could actually do this, right? You could actually say if is sorted s. Sorry, it's s dot begin to s dot end. See out. Let's see, there we go. We could just do that, but if you had to write the function to determine if a string is sorted already, if it's in alphabetical order, how would you do it? Maybe try and use less than or greater than operator to compare strings. Make sure the ASCII value of the next letter is larger than the previous. A for loop. You could loop over every element in the string and see if each one is greater than the one previous to it. Sure. You could. For loop with operators. Okay. Here's how I would do it. If you don't want to use this sorted, I'd probably use it sorted. I'd probably do this. I'd probably do it super inefficient. I'd probably say string s2 is equal to s. Sort s2 dot begin, s2 dot end. If s is the same as s2, then see out s and quit. So again, not the most efficient, easy to write though. So what I'm doing here is I'm sorting all of the letters in hello, let's say, and then it turns into E, H, L, L, O, right? And I'm just seeing if after you sort it, if it is the same string as it was before, print it, and we're done. Right? Does that make sense to you guys? Not the world's most efficient algorithm, but it's fast to write, which has a beauty all of its own. You guys see that? So if you just take the string, you tell C++ sort it alphabetically, sort all the characters in that thing alphabetically. And if it didn't change, it was sorted. So that is a very quick and dirty way of doing it. The correct way of doing it, of course, is just to use is sorted. And then let's see, we should have our answer in a second. The answer is Billowy. So my name, I'm wearing a Billowy shirt, pirate shirt right now. That is the longest letter or series of letters in the English language that are in alphabetical order. Anything go wrong with how I wrote it? No, I don't think so. What are you thinking of? If the vector is empty, the for loop won't run at all. If is sorted is given an empty string, the range won't run at all. This isn't the world's most efficient algorithm. It's order in log n, and it should be order n. That said, the log base n of 2 of 100,000 is not very large. It's like 18. This is like 18 times slower than it should be, but it's fast to write. So, this is the longest excluding special characters. Yeah, it's the same answer I got when I included special characters. So, Let's see what else. What if we just printed out all of them? We could do that too. Okay. So let's get every alphabetized word in the English language. There we go. Of size 3 and greater. Not as many as I would have thought, actually. Beers, billowy, abbot, bellow, effort, glossy, Demos, the moon of Mars. Floppy is alphabetized. Floors, biopsy, naughty. Chintz. Cellos. Achoo. Oops. One of the characters from Grounded. And so accept is in here somewhere. And allow is going to be in here as well somewhere. Anyway. So there it is. Allow. Okay. A foot. The game is a foot. So that is, that was sort of like how I kind of wanted to just walk you through that, because that kind of thing that I kind of came up with last night, like I said, I was at the carnival and I was just having 8 alphabetized things. That's the kind of thing that you would be kind of expected to do within like 15 minutes on like a job interview kind of thing. Like they bring you in, there's a whiteboard, and they're like, here's the problem. How would you solve it? And so what you need to do is that ability to break it down. Like first I need to get a copy of all the words in the English language. Then I need to load it from disk. Then I need to sort it, greatest to smallest, or maybe you do max later. There's other ways you could have done it that are faster actually. And then I need to write a function that'll like tell if it's sorted or not. But wait, maybe there's one already. And you go up on the whiteboard and you just kind of knock it out. And it doesn't have to be like perfect. Like if you forget like how to spell something or something, it's not a big deal. But that's about the difficulty level that would get you a job at a number of companies. Like that was probably harder than the job interview I had at Sony, for example. You know, so the reality of the situation is like most programming problems are not hard. Like a friend of mine just interviewed, and they had him write Fibonacci. You guys all know Fibonacci sequence of 1, 1, 2, 3, 5, 8. Just add the last 2 numbers together. He had to write Fibonacci in 15 minutes. So yeah, with recursion, yeah. So I kind of wanted to just walk you through that process of development, like splitting the problem down and then solving each piece at a time. And a lot of times there's standard library solutions that already kind of do what you need, you know. So you could do it by sorting the string, comparing it with the original string, or if you knew the standard library, just be like, there's a function called isSorted, and it will tell you true or false if it's sorted or not. So I hope that was entertaining and educational for you. Like I said, that's really kind of the level of question you get on like job interviews. And so if that felt like all right for you, that like you would probably be able to, you know, do that with a little bit more experience and things like that, then you're probably in a good place. You're not expected to interview until after 41, you know. So grinding on leet code. Yeah. Okay. Did you guys enjoy that today? Thought that would be kind of a fun little activity. Get you guys a little more practice than you know, the lab time that I've been giving you. So yeah, like I said, a student was saying like it doesn't feel interactive enough, so I'm trying to mix things up for you guys in the online section. There was going to be trivia. Stay tuned. Watch the Halloween channel. It's Halloween tonight, so I gotta take care of the kid first. But I'll post on the Halloween channel, and we can do some rounds of trivia, maybe at like 5 o'clock, something like that. We'll see. Okay. Next time I'm gonna send you some of our code to optimize. Yeah, it could be fun. All right, thanks everyone, and I'll see you guys on Wednesday. Have a great Halloween. Stay safe. Don't eat too much candy. Don't get diabetes. Peace.